This is Intro to Proofs, section 2.2. I'm coming to you on March 20th, 2020. So in this section, for this video, we're going to cover the answers to the 3 preview activities. So I would invite you to attempt those preview activities before watching this video. Otherwise, it's like trying to get stronger from watching someone else lift weights. It just doesn't work that way. So, all right, now, assuming you've attempted the preview activities, let's move forward. So this preview activity begins with a definition. Logically equivalent means they have the same truth value for all possible combinations. And so we write the triple line. Instead of equality, we write triple line, which is equivalence. We say they're logically equivalent. So say, let's complete the truth tables for not P and Q and for not P or not Q. So I've already created some tables here. Let's see. So here, P and Q means it's true as long as both of them are true, and it's false otherwise. So if we negate that, then we get false here and true for the other values. Okay, so here we need to negate P and negate Q. So P is negating that, gives us false, false, true, true. And then negating Q gives us false, true, false, true. And then OR means it's going to be true as long as one of them is true. So here it's false and the others are true. And so we see that these two logical combinations, these two compound statements, are equivalent because they end up with the same values for the same input. So yes, so the answer to number 2 is yes, they are logically equivalent. Now notice we don't say equal because they're not the same thing, but that we say they're equivalent because they give the same result. Okay, oh, I gotta clear those drawings. All right, I'll keep the definition here to remind ourselves, and then number 3 says, suppose that the statement, I will play golf and I will mow the lawn is false. Then its negation is true. So write the negation of this statement in the form of a disjunction. Does this make sense? So if it's not true that I will play golf and I will mow the lawn, then one of those things must be false. So I could say, I have caps lock on. I will not play golf, or I will not mow the lawn. And so that illustrates what we just did in number 2, because I have both nots there and an or. So that's not P or not Q, just like the second part of number 2 back on the last page. Okay. Yep. Now, preview activity number 2 introduces the converse and the contrapositive. So if you have a conditional statement, P implies Q, then the converse is a swap. Q implies P, and the contrapositive is not P implies not Q implies not P. So for each of, for number 1, we're asked to find the truth value of these 4 statements. So here, if x equals 3, then x squared equals 9. Well, that's true. Okay, if x squared equals 9, then x equals 3. Is that true? No, because x could be -3. -3 squared is also 9, so it's false. It doesn't necessarily mean it's equal to 3. Now, if x squared is not equal to 9, then x is not equal to 3. That is true, because if x squared is not equal to 9, then x is not equal to 3. If it were 3, then squared would be 9. So that's true. Now here, if x is not equal to 3, then x squared is not equal to 9. So if x were negative 3, then it's not equal to 3, but then squared it is 9. So it's false. Now, which statement in the list of conditional statements in part 1 is the converse of 1a? Which one is the contrapositive of 1a? So here, the converse of 1a is the backwards, so it's b. In this case, the original statement is true, but the converse is false. Which of them is the contrapositive? The contrapositive is when you swap the order and negate both things. So if x squared is not equal to 9, then x is not equal to 3. Well, that is true. All right, on to preview activity number 3, conditional statements. So imagine a parent telling this to you, or maybe to your younger sibling, or your niece or nephew or something. Or imagine you being a parent and sometimes saying this to your kid. So statement 1, if you do not clean your room, then you cannot watch TV. Statement number 2, you clean your room or you cannot watch TV. Are those statements the same or are they different? Well, one of them is conditional and one of them is an or. So they're not quite the same statement, but maybe they're equivalent. Do they have the same truth value to them? So if you do not clean your room, then you cannot watch TV. So there's like those, we got look through the 4 possibilities. So if statement 1 is true, then you could clean your room. And then if you clean your room, we don't know. Doesn't tell us anything. But if you don't clean your room, then you can't watch TV. Look at statement 2. If you clean your room, so this statement is true. If you clean your room, then it doesn't matter whether or not you get to watch TV. Statement 2 is still true. And if you don't clean your room, then you cannot watch TV because they've got that or statement in there. So they are equivalent. All right, P, B, do not clean your room. And Q, B, you cannot watch TV. So let's translate statement 1 and statement 2 into symbolic form. So statement 1 is, well, let's maybe move this over here. So we've got statement 1 is P to Q. Statement 2 is not P or Q. So those are the 2 logical symbols way of representing that. And then let's construct a truth table for each expression to determine are the expressions logically equivalent? Well, let's see. Oh, I gotta go back. So here, if say P is you do not clean your room and you cannot watch TV, well then that statement's true. If it's true that you do not clean your room and then you do get to watch TV, that would make the statement false. That means that the parent lied. If you do not clean your room and you get to watch TV, so if it's false, if you do clean your room and you get to watch TV, the statement's true. And, oh, I have a typo here. False. This is supposed to be false right there. False. Okay. And so if it's false, false, so that means you do clean your room and you do get to watch TV, then the statement is also true. Now notice this last one here. The parent didn't say if and only if. They just said if. So it only goes one way. So you could clean your room and still not get to watch TV. And they would still have told the truth. All right, now here, so we gotta negate P. So negating P gives us false, false, true, true, and then not P or Q. So As long as one of them's true, it's true. So that's true. They're both false here, so that's false. And this is one of them's true, and here one of them's true. Okay. So we see that, look, they have the same truth values. They're equivalent. Clear the drawings. So assume statement 1 and statement 2 are false. If this is the case, what is the truth value of P and what is the truth value of Q? Okay. So if this were false, if the parent lied, which, I mean, it's really easy as a parent to level an empty threat and then not back it up because you're exhausted. So I hear this parent, but let's say this parent gave an empty threat and the kid pushed the limit and then no consequences. So what happened? If the parent lied or didn't follow through, then that means that the kid did not clean their room and yet got to watch TV. So in symbolic form, that means they did not clean the room and they did get to watch TV, which is the negation of they cannot watch TV. Okay, so that must have happened if the parent lied. Okay, so write a truth table for the conjunction right there. Well, so I've got P, Q, so that means not Q is false, and then true, and then false, and then of course this must be false, it's a typo there, and then true here. And then here, that means P and not Q, so it's false except when they're both true. So there's one false there. Here they're both true, so it's true. You got a double false, and you got a single false here. And then here, P implies Q, so that's true here. It's false here, and then it's vacuously true here, and it's vacuously true there. And then negate it, false, true, false, false. So look, also the same. So we have two also equivalent things. So the negation of P implies Q is P and not Q. It's not another implication. That's important. The book talks about that. Okay, let's clear all the drawings. And that'll be the end of this video, and I'll cover the next video next.